Hello and welcome to this learning video. In the last learning video, we have started the linear programming problem which comes under the optimization techniques. So in that last lecture, we have started with the very basic of LPP, and we have seen the importance of what are the importance of optimization techniques in the last learning video. So here we are going to formulate the given problem as an LPP. Okay, so without wasting much of time, let us start with the problem. Okay, so this problem says, don't bother about this lengthy problem. You will see the problem is although very lengthy, but solution is going to be a little bit simple. The only thing is you need to read the problem very nicely and understand the things which is given here in this. Okay, so what is this problem says? A manufacturer produces two types of models, M1 and M2. So I will suggest you to, before you formulate the given problem, draw the table if possible. Okay, so we have how many models? We have two models, M1 and M2. Is it okay? Now see, each M1 model requires 4 hours of grinding and 2 hours of polishing. So here I will write grinding and here polisher, so polishing. Okay, now this M1 models requires 4 hours of grinding and 2 hours of polishing. Is it okay up to this? As this is the very first problem, so go with ease. Okay, now whereas each M2 model requires 2 hours of grinding and 5 hours of polishing. Is it okay up to this? Now the manufacturer has 2 grinder and 3 polishers. Okay, so 2 grinders and 3 polishers. So we'll make use of this later on. Each grinder works for 40 hours. And how many grinder we have? 2. So what is the available time? 40 into 2, that is 60. So I'm going to make here available time. So for grinding we have 40 hours and we have 2 grinders. So this is 80 hours of available time is there. Okay, and polisher works 60 hours a week. Okay, so what is it? 60 hours is the time for each grinder. So how many grinder we have? We have 2 grinder and 60 hours for polishing. So how many polishers are there? 3. So 60 into 3, that's 180 hours a week. Any doubt up to this? If you can make this table, all the things would be very simple for you. The only you just need to draw this table properly. This becomes the table. Now once this table is made, the rest of the thing is very simple. Okay, so just continue the solution with this. So to formulate an LPP, I have to make use of variables. So let us make use of the variables now. Okay, let x1 and x2 be, let x1 and x2 be the number, of M1 and M2 model, of M1 and M2 models, M1 and M2 models produced by a manufacturer, by a manufacturer manufacturer. Okay, then the weekly product, then the weekly product, sorry, weekly profit, not the product, then the weekly profit of course in rupees is given by okay. So how much is the profit we have? So it has on M1 3 rupees and on M2 we have 4 rupees of profit. So whenever there is a problem of profit, everyone has to maximize the profit and minimize the loss. So this problem is of profit. So my objective function would be maximize Z is equal to, what is the profit on M1? 3. So this is 3x1 plus, what is it? 4x2. Okay. Okay. Now we have to maximize this objective function 3x1 plus 4x2, and to maximize this profit we have what we have the certain constraints. And what are these constraints? These are the constraints. So I am going to write subject to constraint, subject to constraints. What is it? This 4x1 plus 2x2 is less than or equal to 80 hours. Okay, and next 2x1 plus 5x2, so what is the available time? 180 hours. And these x1 and x2 being the number of models M1 and M2 produced by a manufacturer, so it is going to be a non-negative quantity, x1 x2 greater than equal to 0. So this is the required formulation of the given problem as an LPP. Okay, so I hope the problem that we have taken is clear to you. So thank you for watching, and in the live session we are going to take some more problems under this topic. So thank you and keep learning. Thank you.